All right. I'm going to do a video for the materials covered in class December 14th for A Day, December 15th for B Day, and it should be the same stuff. So the starter for December 14th and 15th is solve by completing the square. So what we need to remember is to solve by completing the square, we need to have the form x squared plus bx equals d. Right now the 36 is in the way. So we're going to move the 36 by subtracting a 36 from both sides. So we'll subtract the 36 from both sides. And then we have x squared minus 14x equals negative 36. We are going to look at the coefficient of x. That's our b value. So we look at the b value, which is negative 14. We cut that in half. So we do b divided by 2. Coefficient of x divided by 2. So we get negative 7. We square that value. We get positive 49. So this would be the c that we have to add to our x squared plus bx. There's our plus c, our constant, that will make that a perfect square trinomial. Whatever we do to one side, we do the same to the other. So we're going to add 49 to both sides. We are now going to take this trinomial, 3 terms, 1, 2, 3, trinomial. We're going to write it as a binomial squared. What binomial? It's going to be x and then plus b over 2. But my b over 2 is negative 7. So x minus 7 squared. Remember, it always factors as x plus b over 2 squared. Negative 36 plus 49 is, what is that? 13. Negative 36 plus 49. We'll grab a calculator and test it out. 13. It is 13. I'm just going to change that. It looked a little funny. We're going to take the square root of both sides to undo the square. We're going to do a plus or minus on the square root on the 13. So plus or minus square root of 13. Okay. Square root undoes the square. And square root of 13 doesn't simplify because 13 is prime. To get the x by itself, we have to add a 7. Notice the location where we're putting the 7. So we're going to do 7 plus the square root of 13 or 7 minus the square root of 13. We're just going to leave that 7 right in front of the plus or minus. You could write it this way, plus or minus square root of 13, and then add your 7 back here. But we usually put it in front of the plus or minus sign. It's just more common to do that. Okay, we're going to do a couple more examples, solving by completing the square, and then we're going to talk about radicals. So we're ready for both quizzes. Okay, so 3x squared plus 61 equals 25. We're supposed to solve that equation. Notice the form or the structure of the equation. First thing we're going to do is we're going to isolate the x squared, because we can easily do that by subtracting a 61 and then dividing by a 3. And then we'll undo the square by doing a square root. Okay, 25 take away 61 is negative 36. 25 subtract 61 is negative 36. We're going to divide both sides by 3 because we're undoing multiplication. Negative 36 divided by 3 is negative 12. And now we can solve for x by taking the square root of both sides. So notice the steps that we went through to isolate the x squared. And notice the structure of the original equation, why we're able to do this. Because there's an x squared and no other variable in the entire equation. Okay, so x is going to equal plus or minus square root of negative 12. Because the square root is going to undo the square. We're going to remember that the square root of a negative number is an imaginary number. We're going to identify that by bringing the negative out as an I, and then we'll simplify the radical. Remember, when we're doing the square root of a negative, first thing we do is the negative comes out as an I, and then we simplify the radical. So that 12, we're going to recognize that it's 4 times 3. The 4 is 2 times 2. There's my prime factorization, 2 squared times 3. So 2 squared times 3. The 2 will come out because the square root of 4 is 2. Notice the location we're putting the 2. Plus or minus 2i radical 3. And we are done. And next question. So these are like section 4.3. This one is also like section 4.3. So we're going to solve this equation for x. Notice the structure of the equation. Right here we have a binomial squared. And a plus 8 equals 18. So we're going to start by isolating the x minus 4 squared. To do that, we're going to subtract an 8 from both sides. So we have x minus 4 squared equals 10. We can now square root both sides to undo the square. X minus 4 squared, square root of all that, equals plus or minus square root of 10. Square root undoes the square. Square root of 10 does not simplify because the only factors of 10 are 2 and 5. So no perfect square factors. And we add 4 to both sides. Again, notice the location where we're putting the 4. 4 plus or minus the square root of 10. Or we could write it this way, plus or minus square root of 10 plus 4. But it has to be adding. It can't be multiplication. It's not 4 times the square root of 10. Right? Typically, we're going to leave it like that. All right, let's review radicals for a minute. So simplifying radicals. We're going to talk about 3 methods for simplifying radicals. So find perfect squares under the radical. Rewrite the radicand. Remember, the radicand is the expression under the radical. Rewrite the radicand as factors that are perfect squares and factors that are not. Rewrite the radical as 2 separate radicals and simplify the perfect squares. Okay, let's look at an example. So the 75. The idea with this one, 75 is 25 times 3. So we rewrite the 75 as the perfect square 25 times 3. Perfect square because 25 is 5 times 5. Okay, we then pull the radicals apart, rewrite it as 2 separate radicals, and we simplify the perfect square radical. Square root of 25 is 5, so we have 5 radical 3. We're using the fact that the square root of a times the square root of b is the square root of ab. And we can use that property in either order to pull radicals apart or to multiply 2 radicals into 1 radical. Okay. This example right here, let's do the square root of 12. 12 is 4 times 3. 4 is a perfect square. If we peel those two, peel the 1 radical apart as a product of 2 radicals, using this property right here, square root of 4 turns into a 2. Square root of 3 doesn't simplify because 3 is a prime. And we have our answer right there. Okay, this method I don't highly recommend because a lot of students don't break them down far enough. So what I usually recommend is using either method 2 or method 3. And most of the time method 2. So work with only the radicand. We use a factor tree. So this one uses the factor tree. We work with only the radicand. Remember, the radicand is the expression under the radical. We split the radicand into 2 factors, and we split those into more factors until everything that we have at the end of these branches, these bottom leaves, are primes. Remember the primes. 3, 5, 7, 11, 13. You need to remember who the primes are. 75 is 25 times 3. Then the 25 we can break down as 5 times 5. We group the prime numbers into pairs. So the 75 will make that 5 squared. There's a pair of 5s here, times a 3. And then the 5 squared comes out as a 5, because the square root of 25 is 5. And we have our answer right here. Leave any unpaired numbers inside the radical. And if you have more than one pair, the numbers that are coming outside are multiplying with each other, not adding. And the numbers that stay inside multiply back together as well. Okay, square root of 108. So we're going to do a factor tree for 108. 108 is even, so it's divisible by 2. 108 divided by 2 is 54. This is where we grab our calculator. 54 is still even, so we can divide it by a 2 again. 54 divided by 2 is 27. 27 is not divisible by 2 because it is odd, but it is divisible by something. It's divisible by 3. So we have 3 times 9. 27 divided by 3 is 9. That 9 is not prime because it's 3 times 3. Every one of our lowest leaves here are primes. I'm not going to circle the 9 because that's not the end of the branch. It went further. Okay, we really should only be circling the lowest leaves. What do we have? We're going to pair them up. So what do we have? We have a pair of 2's right there. There's our 2 squared. We don't have any other 2's. That was it. We have a pair of 3's. But then we have one extra 3. Notice I did not write it as 3 to the 3rd power because I am pairing them up. Split them into pairs. The 2 squared is going to come out as a 2. The 3 squared is going to come out as a 3. And the 3 that didn't have a pair, the unpaired number stays inside. 2 times 3 is 6. This whole idea of multiplying the numbers that are outside. And we have our answer, 6 times the square root of 3. Okay, final method. It's like the factor tree, just a little different way of organizing your factors. So method 3, divide by prime numbers, work with only the radicand again. Notice they keep saying that, work only with the radicand. If I had a number outside, we've already mentioned this, I think, if I had a number outside, that's 12 times the square root of 75. Anything that comes out is going to multiply with the 12 that's already there. Okay. So with this method, we use only prime numbers as our factors. So the 75, we're going to look at that and say, okay, it ends in 5, so it must be divisible by 5. So we're going to start by dividing the 75 by 5. There it is. Okay. 75 divided by 5 is my 15. 15 is still divisible by 5, so I put another 5 out here. So now I have a pair of 5s. And 15 divided by 5 is 3, so my factorization is 5 squared times 3. 5 squared comes out as a 5, and we have 5 radical 3. Very much like the previous method with the factor tree, it's just a little different way of organizing it, but we break it down into primes. Okay, let's do the 504. Square root of 504. So I'm going to start with that and recognize that it's even, so it's divisible by 2. 504 divided by 2. Grab our calculator, it's 252. 252 is still even, so we can get another 2. 252 divided by 2 is 126. Still divisible by 2, so I'm going to take another one. 126 divided by 2 is 63. 63 is not even. It's not divisible by 2, but it is divisible by 7, or by 3 if you want to go to 3. But hopefully we recognize 63 is 7 times 9, so we can go there. And 7 is a prime. We're not done. 9 is not prime. It's divisible by 3. Now we're done, because our last factor here is prime. So again, we're going to pair up the numbers. And we could get the same answer using a factor tree. So we'll pair these guys. There's a 2 squared. There's an extra 2 that doesn't have a partner. There's a 7. And then there's a pair of 3's. Pair them up. Okay, 2 at a time. Square root of 2 squared is 2. Square root of 3 squared is 3. 2 times 7 is under our radical. Those guys didn't come out. The ones that are unpaired stay inside. 2 times 3 is 6. 2 times 7 is 14. And our final simplified version is 6 times the square root of 14. And we are done. And that is the last of the notes for today.